Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abuzena. That channel is especially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject one topic at a time. Thanks so much for staying tuned and being loyal subscribers. God bless. Today's class, which promises to be interesting, enlightening, and most importantly fun, is going to be a continuation of our last video on the topic binomial expansion. In the last video, we introduced the concept of binomial expansion, whereby we explain what binomial expansion is in summary. And then we emphasize that the concept of the Pascal's triangle. As a review, the Pascal's triangle essentially is to list out the coefficients we are going to obtain after expanding a binomial. And from them we learned that for the two values, where the first one is decreasing in powers, the second one is correspondingly increasing in powers. Today, we are going to continue by going in depth into the real binomial expansion proper. And the way to do that is by looking at the binomial expansion formula. So we have a binomial x plus y to the power of n. That's the general formula now. So how do you expand this? The formula is gotten by using the concept of combination. So you have n combination 0, then x power n. Remember, the first value always assumes the full power. Then subsequently, it decreases by 1. So we have n combination 1, x power n minus 1 now, then y power 1, plus n combination 2, x power n minus 2, y squared, plus n combination 3, we have x power n minus 3, y cubed, and so on. This is the binomial expansion formula. However, there's a restriction here. This is only for n being greater than or equal to 2. And also, n must be strictly positive integers or natural numbers. So this formula is restricted because we can't use just any value of n. For n to be applicable here, we have to use n being more than 2 or 2 at least. So we can't use n if it's negative, neither can we use n if it is fractional. Hence the need for us to simplify this formula further. And to do that, we use the very knowledge of our combination. So this is going to become n combination 0, which is 1 anyway, which is 1x to the power of n. Plus, so I'm simplifying this particular formula now. N combination 1 is n factorial over n minus 1 factorial 1 factorial x power n minus 1 y to 1. Then other one, n factorial over n minus 2 factorial, then 2 factorial n raised power n minus 2 y squared. Then plus n factorial over this time around n minus 3 factorial 3 factorial x to the power of n minus 3 y power 3 plus and so on as well. So on simplifying this further, I'm going to arrive at this x power n plus n x power n minus 1 y plus n minus 1 over 2 factorial x power n minus 2 y squared, and plus n minus 1 n minus 2 over 3 factorial x power n minus 3 y power 3, and so on. So this is the more generally applicable formula for expanding binomially, irrespective of the value of n. This applies for all values of n elements of real numbers. So for whatever value of n, as long as n is real number, positive, negative, fraction, decimal, this formula applies to them all. So this is a more refined and more applicable formula for expanding binomial as opposed to this one. So I will recommend this should be committed more to memory than this. Okay, now after looking at the binomial expansion formula, let's now take at least an example to see how it applies. So if we are to, for example, use the binomial expansion formula to expand, of course, and to simplify. You got x plus 2y to the power of 5. So how do we solve this? X plus 2y to the power of 5. So here n is obviously 5, that's our n. X remains x, however, our 2y represents y. So starting here, we just substitute the values directly. So we're going to have x plus 2y to the power of 5. So we go x power 5 using this x power 5 right away, then plus 5 x power 4 and then 2y power 1. Remember I said the 2y represents y, that is what. Then the next value will be plus 5 times 4 over 2 factorial. Look at that, n is 5. 5 minus 1, 4. Over 2 factorial. Then again, x power 5 minus 2, 3. Then the y is actually 2y power 2. At every point in time, remember from the past video that adding the powers will still give us the original 5. So 5 plus 0 here is 5, 4 plus 1 is 5, 3 plus 2 is still 5. That's a quick way to check if you're on track. Then plus 5, 4, 3 over 3 factorial. Then we have the x power 2, 2y power 3. Again, 2 plus 3 is 5. Now plus 5, 4, 3, 2 over 4 factorial. Here is going to be just x power 1 and 2y power 4. Then lastly, you simply have 2y power 5. Just the way the very first value, x here, assumes the entire power 5 here as first term. So also for the last term, the second value, which is 2y in this case, assumes the entire power 5. So going further, I'm going to have x power 5 is just x power 5. Plus, now here, 5 times 2 is 10. That is 10 x 4y. Now plus here, this is 5 times 4, that is 20. This is 2 squared, which is 4. So 20 by 4 is 80. Then divided by these 2 factorial, that's 40. 40 x power 3, and of course y squared. Then the next one we have here, this 3 factorial means is 6 actually. That's 3 times 2 times 1. So 6 in 12 is 2 times 5, that's 10. Then this 2 cubed is 8. 8 times 10, 80. Then we have x squared y cubed plus. Then here we have 4 factorial is 4 times 3 times 2 times 1, which interestingly cancels out this 4, 3, 2. So we are left with just 5 here. So 4 factorial takes care of 4, 3, 2. So we have plus 5 left here. So 2 to the power of 4 there is 16 times 5. That's 80. Then x, y, 4. Then lastly is 32, y, 5. And that is the expansion of the binomial x plus 2y to the power of 5, which I believe you find quite straightforward and interesting. If you have any issue to share about, feel free to revisit the video or by moving back a bit to the points that you find technical. And that will be the end of the lesson today, which has been on the binomial formula or binomial expansion formula, which essentially uses the concept of combination. Thank you for staying tuned, and God bless. See you in the next video.